Hello class, my name is Juan Johnson and this is a video that describes the operation or the design of the control sequence or counter sequence design. This video will go through step by step each of these steps to a solution. So let's begin. First step is the state diagram. Well, the state diagram can be drawn in many different ways. Here is one example of a state diagram, but it's not the official. The official form of the state diagram is to draw circles with the different states inside. So over here on the right, I will draw a 4-step sequence using 4 circles, and in each circle I will insert the value of the next state. I think I made a mistake here. The next state would be 1 0 after 0 0. The next state would be 0 1. The next state will be 1 1, and then it will return back. You must also include these arrows if you want to receive credit for the completion of your state diagram. So this is the official state diagram. Okay. So we have just completed step number 1. Now step number 2 is we need to create a next state table. To create a next state table, what we do is we generate a truth table for all the possible values, and then we write the next state that would proceed after that. So we want to formulate a truth table based on the counters that we're going to use. We're going to need 2 flip-flops in order to succeed in operating this counter. The reason why is because there are 2 outputs here, a 0 and a 1, or 2 digits for each state. So we need 2 flip-flops to represent those 2 states. For that reason, we will need a Q1 and a Q0. So we should create the truth table for the possible values of Q1 and Q0. So as we learned, in the first column we just alternate between 0 and 1, and then in the second column is 00 and 11. So this will be considered the present state. Now on the right side is where we would use our next state diagram to determine what the next value should be for each of these outputs. So if it's 0 0, the next value should be 1 0 according to our state diagram. After 0 1 should be a 11. After 1 0 should be 0 1, and after 11 it recycles back to 0 0. Now to distinguish or to separate the current state with the next state, we normally put a sign called a prime, P-R-I-M-E, a prime symbol to represent the next state. So over here would be the present state, and this is our objective. Our objective is to get to the next state, which means that we have to be sure that the values of the truth, the J and K, will be in the right position in order for the flip-flops to transition to the next state properly. So we need to create a combinational network that will convert these inputs from the flip-flops into the proper values of J and K that will give us the outputs that we need. So I'll stop the video at this point, and you can start the next video for step number 3.